Assalamu alaikum. Hi guys, my name is Atta and today topic is about fluid mechanics. Fluid mechanics science concerned with the response of fluids to forces exerted upon them. It is a branch of classic physics with applications of great importance in hydraulic, aeronautical engineering and chemical engineering, meteorology and zoology. The most familiar fluid of the course is water and an encyclopedia of the 19th century probably would have dealt with the subject under the separate of headings of hydrostatics. The science of water is at rest, and hydrodynamic, the science of water in motion. Archimedes founded hydrostatics is about 20 to 50 BC when, according to the legend, he leaped out of his bath and ran naked through the streets of Syracuse crying in a car. It has undergone rather little development since the foundation of hydrodynamics, on the other hand, were not laid until the 18th century when mathematicians such as Leonard Euler and Daniel Broglie began to explore the consequences for a virtually continuous medium like water of dynamic principles that Newton had enunciated for systems composed of discrete particles. Their work was continued in the 19th century by several mathematicians and physicists of the first rank, notably G. Stokes and William Thomson. By the end of the century, explanation had been founded for a host of integrating phenomena having to do with the flow of water through tubes and orifices. The waves that ships moving through water leave behind them raindrops of on window panes and the like. There was no proper understanding, however, of problems as fundamental as that of the water flowing past as fixed obstacle and exerting a drag force upon it. The theory of potential flow, which worked so well in other contexts, yielded results that at relatively high flow rates were grossly at variance with experiment. This problem was not properly understood until 1904 when the German physicist Ludwig Pandry introduced the concept of boundary layer. Prandtl's career continued into the period in which the first manned aircraft were developed. Since the time, the flow of air has been much interest to physicists, and the engineer has the flow of water. Hydrodynamics has consequently become fluid dynamics. The term fluid mechanism is as used here embraces both fluid dynamics and the subject still generally refer to the hydrostatics. Now we are going to discuss about basic properties of fluids. Fluids are not strictly continuous media in the way that all the successors of Euler and Brownlee have assumed, for they are composed of discrete molecules. The molecules, however, are so small and except in the gases at very low pressure, the number of molecules per milliliter is so enormous that they need not to be viewed as individual entities. There are few liquids known as liquid crystal in which the molecules are packed together in such a way to make their properties of medium locally anisotropic. But the vast majority of fluids, including air and water, the isotropic in fluid mechanics, the state of an isotropic fluid may be completely described by defining its mean mass per unit volume, or density or temperature, and its velocity at very point in this space, and just what the connection is between these macroscopic properties and positions and velocities of individual molecules is of no other relevance. A word perhaps is needed about the difference between gases and liquids, through the difference is easier to perceive than to describe them. In gases, the molecules are sufficiently far apart, move almost independently of one another, and gases tend to expand to fill any volume between. In liquid, the molecules are more or less in contact, and the short range attractive forces between them make them cohere.